Hello everyone, and welcome to another episode of School Math versus Contest Math. Today we're going to look at two different infinite geometric series. So, in this School Math one, we have one that's pretty basic, 1 over 10 to the first power plus 1 over 10 to the second power plus 1 over 10 to the third power, and on and on and on, till infinity. Now, how do we solve this? Well, basically the idea here, as does most school math questions, is pretty much one or two equations. That's really how school math works. And so in this case, the equation that you have to know is a divided by 1 minus r. Now, let's see what this means. A means the first term of the series, in this case 1/10. And then r is the common ratio between each and every term. So let's see, what's the common ratio? That means the first term times what equals the second term times what is equal to the third term times what is equal to the fourth term, and so on and so forth. So let's see, 1/10 times something equals 1 to the 10 squared. Well, we're just multiplying 1/10 by 1/10 again to get another 10 in this denominator. So clearly r is equal to 1/10. So if we just plug in values now, we get 1/10 divided by 1 minus 1/10. And now it's pretty easy. You just simplify. So you get 1/10 divided by 9/10. So now, almost done, you get 1/10 times, you flip the denominator over, 10 over 9, 10s cancel out, you get 1/9 as your answer. So, very easy, just one step to this problem, as does a lot of questions in middle school and high school, but that's just how it is. Let's look at a contest math question that uses an infinite geometric series right here. So it's almost the same thing except for one pretty important thing. Instead of 1 divided by 10 plus 1 divided by 10 squared, it's 1 divided by 10 plus 2 divided by 10 squared plus 3 divided by 10 squared plus 3 divided by 10 cubed plus 4 to the power of 10 divided by 10 to the power of 4. Basically, the 10 to the power, you can say the nth term is n divided by 10 to the n. So the number in the numerator is equal to the exponent in the denominator. So how do we solve this? Well, let's try to use a over 1 minus r, the formula for finding an infinite geometric series. Well, we know our first term, a, is 1/10. That's pretty easy. But this is the problem right here. What is the common ratio? Is there even a common ratio between all of these numbers? There doesn't seem to be one, because 1/10 times something equals 2 over 10 squared. That something is not equal to 2 divided by 10 squared times something equals 3 divided by 10 cubed. Therefore, there is no common ratio. This times something to get that is not the same as this times something to get that. So what do we do here? So this is where the contest math ideas come in that you have to be pretty mischievous in how you solve this. So one thing you can do is that you can actually split these up. So 2 divided by 10 squared is the same thing as 1 over 10 squared plus 1 over 10 squared. So let's do this. 1 over 10 plus 1 over 10 squared plus 1 over 10 squared. These two terms are the same as this when you add them up. And then 3 over 10 cubed is just the same thing as 1 over 10 cubed plus 1 over 10 cubed plus 1 over 10 cubed. And then we can do the same thing for 4 over 10 to the power of 4 plus 1 over 10 to the power of 4 plus another 1 to the power of 10, 1 divided by 10 to the power of 4, plus 1 over 10 to the fourth plus 1 over 10 to the fourth. And we can do the same thing for 5 divided by 10 to the power of 5, but I'm not going to waste time doing that. So we have this series. So this series is the same as this. We just rewrote it in this way. Now, how is this beneficial? Well, this is the key idea. Inside this series are an infinite number of these series. So, if you don't believe me, that's okay. It's kind of a weird thought, but let me show you this. Let's say, can we extrapolate the previous series that we had from this series? Yes, we can. We have a 1 over 10 plus 1 over 10 squared plus 1 over 10 cubed plus 1 over 10 to the 4th plus 1 over 10 to the 5th. Basically, we have our school math infinite geometric series problem hidden inside this. So let's just do that. So if we take the if we take a over 1 minus r for that series that's hidden inside this series, we get the same as what we had here. So we had 1/10 as our first term divided by 1 minus the common ratio, which is 1 over 10. Now, believe it or not, there are an infinite number of these types of infinite geometric series in this one series. So, let's see. Well, we used this and this and this and this for our series. But keep in mind, we only used 1 over 10 squared. What about the other one? We didn't account for that in here. So let's account for it again. So we take that, and let's see. We have 2 1 over 10 to the cubes that we didn't account for. So let's just account for another one of them. And we have 3 1 over 10 to the 4ths that we didn't account for. So let's account for one of them. So hopefully you see this. The next series we're going to do is pretty much the exact same series as this, but instead of the first term being 1 over 10, the first term is going to be 1 over 10 squared. So our next term is 1 over 10 squared, which is our first term, but with the same common ratio. And then we can do the same thing for 1 over 10 cubed. We already used 2 of these 1 over 10 to the cubed, 10 to the power of 3, so there's 1 more left. So we take that, and then 3 of these were used, 1 over 10 to the 4th, so let's use one of them again. So we got 1 over 10 to the power of 3 plus 1 over 10 to the power of 4 plus 1 over 10 to the power of 5. And if we use our a over 1 minus r, first term is 1 over 10 to the power of 3 over 1 minus 1/10. So hopefully you can see this. There's going to be an infinite amount of these mini infinite geometric series. That's pretty weird. Mini infinite series. That's pretty weird to think about, but that's pretty much how it is. So we can continue on again and again and again for 1 over 10 to the power of 4, 1 over 10 to the power of 5, and so on and so forth. So now we just have to sum up all of these series and then we'll be done. Well, we could try to sum this infinite series, then this one, then this one, then this one, then this one, blah, blah, blah. But that's going to take about an infinite amount of years, so let's try to think of a better way to do it. Well, think about it. The denominators are the same for each one. We can combine these fractions. So we can get 1 over 10 plus 1 over 10 squared plus 1 over 10 cubed plus ... all over 1 minus 1 over 10. So we now took all this infinite amount of fractions and combined it into one. So does this get us anywhere? Well, yes, it does. We can take this numerator, 1 over 10 plus 1 over 10 squared plus 1 over 10 cubed, ding, 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 ding. This is the school math problem we did about like 5 minutes ago. So let's just do that. Let's just take the infinite series of this numerator. So first term is 1/10 all over 1 minus r, which is 1/10. And don't forget there's a denominator over here, 1 minus 1/10. And now we just have to simplify and we'll be done. So let's see. Let's go from the bottom, from the top down. So that equals 1/10 over 1 minus 1/10, 9/10. All of that over 1 minus 1/10, which is also 9/10. So let's see. Numerator 1/10 divided by 9/10 is the same thing as 1/10 times 10 over 9. In this case, it's 1/9, this term. And that's still divided by 9 over 10. So let's see. Well, one more step. 1/9 divided by 9/10 is the same thing as 1/9 times 10 over 9. Multiply the numerators together, multiply the denominators together. 10 over 81. Voila. Took a while, took a bit of logic, but we finally got it. So I hope you can see the difference between these two types of problems. This contest math problem, we had to use a lot of logic. We couldn't just use one single equation. We had to use the equation multiple times and use a little bit of wishful thinking in order to get the answer. But for the school math one, just one equation. And that's what most high schools and middle schools do anyway. But if you want to really do well in a contest math problem, you gotta remember, be logical. Make it a great day.